This is Math 090 Week 2, Part 2 of the lecture. We're going to look at Section 1.2, Introduction to Algebra and the Set of Real Numbers. So firstly, a variable is a symbol or letter used to represent a value that is subject to change. So a simple example would be the number of hours worked per week. Say you make $7 an hour. Well, how much money are you going to make per week depends on how many hours you work per week, and that can fluctuate. So we can represent the amount of money made per week by 7 times, we'll call it X, our variable. X represents the number of hours you work per week, which can change. So if you work 10 hours, 7x means 7 times x. So 7 times 10 would be 70. If you work 11 hours in that week, 77, and so on and so forth. So the variable x represents something that can be changed. A constant is a value that is not subject to change. So it's just a number. Say a manufacturer makes widgets and the manufacturer has to rent the building that they make the widgets in. And say the rent is $1,400 a month. Well, they want to know how much they spend per month. Depends. The number of widgets they make can change. So say it costs them $10 to make every widget. So X would represent the number of widgets, and 10X represents 10 times the number of widgets. But that $1,400 a month doesn't change. So that's like a fixed cost or an unchangeable cost, which is a constant. So for instance, if they made one widget, 10 times 1 plus 1,400, 10 times 1 is 10 plus the 1,400 gives us $1,410 that they spent in that week, or that month, sorry. Well, say they made 100 widgets, 10 times the 100 widgets plus the $1,400 it costs to rent their building. So it costs $10 to make each of the 100 widgets, so that's $1,000 it costs them to make those widgets, plus that fixed $1,400 rent. So in that month that they made 100 widgets, it costs them $2,400. Okay, so an algebraic expression is a collection of variables and constants. What we wrote here, 7x, that's an algebraic expression. 10x plus 1,400, that's an algebraic expression. It's a collection of variables and constants. So in the expression 2x plus 4, x is a variable and 4 is a constant. Now when we evaluate an algebraic expression, this means we're going to replace the variables with given values, just like we did with our examples here. We said x was the number of hours worked. Well, if they tell us to work 10 hours, we replace x with 10. If they tell us to work 11 hours, we replace x with 11. When we made one widget, we replaced x with 1. When we made 100 widgets, we replaced x with 100. So we evaluated our expressions for given values. We replaced the variables with our given values. And it is a good idea when you are evaluating expressions to first take your expression and replace your variables with parentheses. So then when you're given the values of those variables, you can drop them right in the parentheses. And this will also help you keep your signs straight. When we start talking about positive and negative numbers, this helps you keep your negatives in order. So in the expression n plus m over 8, I'm going to replace n with the parenthesis and m with the parenthesis. Now, n is equal to 33, so I'm going to drop that 33 into n's parentheses. M is given to us as 72, so I'm going to drop 72 into the parentheses for m. From here, you then go ahead and do your calculations. 72 over 8 is a fraction that reduces to 9. You can think of it as 72 divided by 8, that's 9. So we have 33 plus 9, which gives us 42. So this expression, n plus m over 8, is equal to 42 when m is 72 and n is 33. This particular expression, 8h minus g, h is given to us at 6, so we have 8 times 6, minus g is given to us as 7. So 8 times 6 is 48, minus 7, 48 minus 7 is 41. Okay, so real numbers are 0 and all your positive and negative numbers, including the numbers between your whole numbers and integers. So remember, these numbers in between the whole numbers and integers are represented by fractions and decimals for the most part. So the set of real numbers can be represented graphically on a horizontal number line with a point labeled as 0. All the positives are on the right, all the negatives are on the left. So we might remember from back in grade school, we called this the real number line. 0 itself is neither positive or negative. The farther left you go, the further negative you get, and the smaller the numbers become. The farther right you go, the more positive you get, and the larger the numbers become. So think about this. -5 is less than -1. Even though the number 5 is bigger than the number 1, the opposites, or the negatives, go in the opposite direction. So as we go to the right, -4 is bigger than -5, -3 is bigger than -4, -2 is bigger than -3, and so on and so forth. So we want to plot the numbers 8, 11, and -6 on a number line. So first, look at your number line. It gives us 0, 5, and 10, and -5 and -10. So each of these is counted as 5s. In between, look at how many subdivisions, we'll call them. So there's 1, 2, 3, 4, 5. So that means this first tick is 1, the second tick is 2, the third tick is 3, fourth is 4, 5, 6, 7, and here would be your number 8. Then if we keep going, 9, 10, this would then be your number 11. And now -6 goes to the left of 0, so we go -1, -2, -3, -4, -5, -6. What is the position of E on the number line? So notice on this number line, we have a 0 and a 1. Then we have subdivisions between 0 and 1. The same number of subdivisions between 1 and 2, the same number between 2 and 3. So each of our whole numbers is subdivided into 5 parts. Each of these parts represents 1/5 of the whole number 1. So this would be 1/5. This one and this one makes 2/5, 3/5, 4/5, and then 5/5, which is the same as the number 1. So each one of these ticks is a fifth. 1/5, 2/5, 3/5, 4/5, 5/5. Then here, this would be 6/5. And as a mixed number, remember that would be 1 and 1/5. 1 and 2/5 or 7/5. 1 and 3/5 or 8/5, so on and so forth. So if we look at E, we have 2, 2 and 1/5, 2 and 2/5, 2 and 3/5. So let's remember 2 and 3/5. If we turn that back into an improper fraction, we have 5 times 2 plus 3 all over 5. So that's 10, 11, 12, 13 fifths. So E is at 2 and 3/5, which is also 13 fifths. So as a mixed number, it's 2 and 3/5. As an improper fraction, it would be 13 fifths. Now let's plot -1 1/3, then also 5/6 on the number line. Investigating our number line, we see between each whole number, there's 6 subdivisions. So each of these subdivisions is 1/6 of a whole. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6 or 1 and 1/6, 8/6 or 1 and 2/6, so on and so forth. But notice our mixed number has a fraction whose denominator is 3. So if we have, here's 0 and here's 1, and we have 6 subdivisions. 1, 2, 3, 4. Okay. So this is 1/6, 2/6, 3/6, 4/6, 5/6, and then 1, remember, 6/6 is the same as 1. Now think about this. 2/6 can be reduced to 1/3. 3/6 can be reduced to 1/2. 4/6 is 2/3. So these marks actually have different equivalent fraction representation. So 2/6 is the same as 1/3. So every 2, so this is 2/6 or 1/3. This is 1 and 2/6 or 1 and 1/3. If we go backwards, this is -1. This would be -1 and 2/6 or -1 and 1/3. So every 2 would represent another third. So this would be 1/3. Go 2 more and you get 2/3. Here again, this would be 3/3, which is still the same as 6/6, which is the same as 1. So -1 and 1/3 would be 2 tick marks passed to the left of -1. Now 5/6 would be 5 marks, 1/6, 2/6, 3/6, 4/6, 5/6 to the right of 0. Okay, so where is C? Well, let's count the subdivisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one of these tick marks is a tenth. So let me see, was that 0? Oh. 1, 2, 3, and we have 10 subdivisions. Now, instead of using fractions, we're going to use decimals. So there's 10 subdivisions. Each of these tick marks represents a tenth. As a fraction, a tenth looks like this. As a decimal, a tenth looks like this. The first decimal place is the tenths place. So each one of the tick marks is a tenth. So we have 0.1, 0.2. Actually, this is 1. So 1 and 1/10. 1 and 2/10. 1 and 3/10. 1 and 4/10. All the way up to 1 and 9/10. 1 and 10/10, or 2. Then we have 2 and 1/10, 2 and 2, 3, 4, 5, 2 and 5/10, 2 and 6/10. Each tick is a tenth. So 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 5, 6, 7, 8, 9, 2. 2 and 1/10, 2 and 2/10, 2 and 3, 2 and 4, 2 and 5, 2, 6, 2 and 7/10, 2 and 8/10, 2 and 9/10, 3. So what did we, oh, it was 1, 2, 3, 4, 5 ticks past 2. So this is 2 and 1/10, 2 and 2/10, 2 and 3/10, 2 and 4/10, 2 and 5/10, which is right here, 2.5, 2 and 5/10. Now looking at this number line, we have 5 and 6/10 and 5 and 7/10. Then we have 10 more subdivision. So tenths divided into 10 more is our hundredths. So the hundredth is the second decimal place. So this is 5 and 6/10 and 0 1/100ths. This is 5 and 6/10 and 1 1/100th, which would be 5.61. Okay, so we have 5.6 and 5.7. Then we have 10 more subdivisions. So each subdivision is a hundredth, and it is the second decimal. So this is 5.61, 5.62, 5.63, so it's 5 and 63/100ths, 5 and 64/100ths, 65, 66, 67, 68, 5 and 69/100ths. Then we go to 5.7. And our mark is 5.6. This is 6.1, 6.2, and this would be 6.3. Okay, so we've seen that the numbers between integers are partial numbers. They can be represented as fractions or decimals. So fractions and decimals are very closely related. Most can be converted into each other. So we saw the fraction 1/10 is equivalent to the decimal 0.1. So in order to write a fraction as a decimal, we do the division. Remember, we said in a fraction, it's like saying the top is being divided by the bottom, or the bottom is being divided into the top. So if we do these by hand, 6 over 25, this is saying 6 divided by 25, or 25 divided into 6. So we have to remember our division, our long division. This can easily be done in a calculator. You punch in 6, the division symbol, and 25, and it'll spit out the decimal. If you're doing them by hand, 25 goes into 6 0 times. 0 times 25 is 0. Do your subtraction, and we end up with the remainder of 6. Well, we want to end up with the remainder of 0. So we add a decimal point after the 0 on top, then after the 6, and we add a 0, and then we drop down and carry or bring down the 0. Now we're dividing 25 into 60. Whatever number that is goes after our decimal point. Well, we know 25 times 2 is 50. 2 times 25 is 50. So we have 10, which is still not 0. So we add another 0, carry it down. 25 goes into 100 4 times. 4 times 25 is 100. Well, now we finally have 0 as a remainder. So 6, the fraction 6 over 25 is the same as the decimal 0.24. So you keep doing the division until you end up with 0 as a remainder. Now, sometimes you're going to end up with repeating decimals. So this means no matter what you do, your remainder is going to come out the same over and over and over. We call that a repeating decimal. And to signify that, we use a repeating bar. And it's very important to understand the bar goes above only the digit or group of digits that repeat. So 13 divided by 6. Six goes into 13 twice would be 12. We have a remainder of 1. So we need our decimal, carry the 0. 6 goes into 10 once. 1 times 6 is 6. We have a remainder of 4. So we need another 0. 6 goes into 40 6 times. 6 times 6 is 36. Carry a 0 down again, and again, 6. And notice, 6 times 6 is 36, so we're going to keep getting this 4 and carrying down the 0, so this 6 is going to repeat. So the decimal representation of 13 over 6, the fraction 13 over 6, would be 2.16, and the bar goes only over the 6. Because only the 6 repeats. The 1 does not repeat, so you don't want the bar above the 1. Only the 6. Okay, so we turned fractions into decimals. Now we're going to turn decimals into fractions. So the easiest way to think about it, your denominator is going to be the place value of the last digit. No matter how long your decimal is, whatever place value the last digit is in, that's your denominator. Then all the decimal numbers, all the numbers are put in the numerator minus the decimal point. So if we think about 0.8, that's red. We read it in the English language as 8/10. So 8 is in the 10th place, that's your denominator. And the only digit here is 8 or 0.8, but 0 doesn't count. A 0 before the decimal is nothing, so. And we disregard the decimal, so we put 8 over 10. But remember, with fractions, you always have to make sure they are reduced. 8/10 reduces to 4/5. So let's do a couple more. Let's say we have 0.12. Well, our numerator is going to be 12. The denominator, 1 is in the tenths place, but 2 is in the hundredths place. But be careful, we have to reduce this. They're both even, so I know I can divide a 2 out. I can divide another 2 out. So 0.12 is the same as 3 over 25. 1.6, the numerator would be the 1 in the 6. The denominator would be 10. 6 is in the tenths place. 16 tenths reduces to 8/5. So all the digits, disregarding any leading zero and the decimal, and is your numerator, and the denominator is the place value of the last digit. $75/100. Again, all our digits, disregarding the zero and the decimal point. So that's 75. 5 is in the hundredths place, so that's your denominator. Then, if you can, reduce it. 75 is divisible by 25, and so is 100. So 75 or 0.75 is the same as 3/4. Ordering numbers. Now, like we said before, the further left you go on a number line, the smaller you're getting. The further right, the larger you're getting. These symbols have specific labels. This symbol is always read as less than. When the point is pointing to the left, this is read as less than because we read from left to right. So whatever is here is less than whatever is here. This symbol is greater than, because again, we read left to right. So if the number on this side is bigger than the number on this side, we read it as this number is greater than this number. Then the equal to sign means whatever is on either side of the equal sign are equal. If this is 5 and this is 4 plus 1, 5 and 4 plus 1 have the same value, so they're equal. So looking at, let's see, we have -2, oops, sorry, is being compared to -6. Well, if we think about our number line, -6 is out here and -2 is here. So -2 is actually greater than -6. Had these numbers been written in the opposite order, had they put -6 first and then -2, we would say, well, -2 is, or -6 is less than -2. So these can be written either way. -6 is less than -2 means the same thing as -2 is greater than -6. Let's think about it with positive numbers. 8 is greater than 5. 5 is also less than 8. So these expressions can be read, you always read left to right, but they mean two different things. 8 is greater than 5, and also 5 is less than 8. Okay, so 5 and 8. 5 is less than 8, and -10 is less than 0. -10 would be way out here, and 0 is here. 5 is here, and a +8 would be way out here. Ordering numbers, especially when they're decimals. When all you have is whole numbers and you have to put them in order, it's pretty easy. But when you have decimals, you have to compare place values. So, starting on the left, we have an 8, a 6, a 6, and a 6. Well, these 3 6s don't tell us anything, but the 8 tells us that this is the biggest number. So if you want to write it this way, we can also, let's see if I can move this over. Remember, we can do this way, or we can say 8.520 is greater than the next number. So the way they have it written here, you're going from least to greatest, and that's what it tells us to do. But it also means the same thing if you go from greatest to least. So I know the one that has 8 in the ones position is the biggest number. So I'm going to put that all the way to the right. Now we have to look at the sixes. The sixes don't tell us anything, so you go to the next decimal place. We have a 1, a 9, and a 1. The 9 is bigger, so it's going to be in the next position right here. So this would be 6.900. And another thing, if you don't have the same number of decimal places, sometimes it helps to replace those empty values with zeros, just to keep everything organized. Okay, so we have the 8.520, we have the 6.900. So the next smaller number, we had the 6.1 and the 6.1. We have a 6.17 and a 6.10. Well, 6.17 is greater than 6.10 because 7 is bigger than 0. So that would be right here, the 6.17 or 6.170. Then the smallest number of the bunch is the 6.107. That would be right here, which is shown down here, or 6.107. So if we numbered them from greatest to least, or least to greatest, these are the orders they would be in. Writing fractions in order. The easiest way to put a fraction in order is if they have the same denominator, because then all you have to do is compare the numerators. So you have to rewrite your fractions with the common denominator. We have 9/10 and 13/15. So finding common denominators, our denominators are 10 and 15. What I tend to do is look to see if one denominator is a multiple of the other. If it is, then that denominator is your common denominator. If it's not, I pick the larger of the two, which is 15, and I create multiples of 15 until I find something that the other number divides into. So I can easily see that 15 times 2 is going to give me 30, and 10 goes into 30 evenly. So 10 times what number is 30? 10 times 3. So then you find your numerators. If I multiplied 15 times 2, I have to multiply 13 times 2, which gives me 26. 10 was multiplied by 3, so 9 has to be multiplied by 3, which is 27. So instead of comparing 9/10 and 13/15, I'm going to compare 27/30 and 26/30. And all I have to compare is their numerators. Well, 27 is bigger than 26, so I use my greater than symbol. 27 is greater than 26, so this means 9/10 is greater than 13/15. Because 27/30 was equivalent to 9/10 and 26/30 was equivalent to 13/15. So with fractions, you want to find common denominators. With decimal values, you compare their corresponding place values. Compare all the ones places, then the tenths, then the hundredths, thousandths, so on and so forth. But with fractions, you want to create equivalent fractions with the common denominator. Then you just compare numerators. And that is the end of part 2.